Hello everyone, welcome back. In this video we're going to step through a simulation of the common emitter amplifier circuit. I've already drawn up the circuit here in LTspice, so you don't have to we don't have to watch that in this video, but other videos I'll start from scratch and I'll build up the circuit. We have V in, this source over here. If I right click on this source, I've set it up as a sine wave with a 0 DC offset, amplitude of 10 millivolts, frequency of 100 kilohertz, AC amplitude 1, I don't know what that is. Oh, okay, AC 1. I see. So we'll leave it off for right now. And so we're going to run two simulations. Edit simulation command. We're going to first run the transient. After that, we're going to run the AC analysis. These other ones, your professor may step you through how to run them, but I'm just going to run the first two. Cancel. Okay, so simulate, edit simulation command, transient, stop time of 1 second, and start saving data at 0.999. Okay, I'm going to set this near that source, hit save, and click run. The simulation down here is 92% complete. View window, tile vertically, so it's like this. There's too many cycles on the screen, so I'm going to add another 9. So I'm going to say simulate, edit simulation command, put another 9. That'll take away 10 of those. That may not even be enough. Run. We're at 50, 60, 70, 80, 90. Done. That's good enough. Okay, so we see 10 millivolts peak to peak, and we see 25 millivolts peak to peak. So a gain of 2.5, something like that, 25 over 10. So 2.5 for these values. Given that we have a potentiometer right here, the gain will be variable. And given that we have a potentiometer in this network up here, the gain will also be variable. Let's just exactly. So we have a potentiometer here in this resistor network. That will affect the gain. And we have this resistor here in this network. That will affect the gain. So you can experiment with adjusting the gain, but otherwise we should expect a gain of between 2 and 3. Okay, so that's the first analysis that I wanted to run. And this is at 100 kilohertz. Okay, the next one that I want to run, edit simulation command, AC analysis. Type of sweep, let's say linear. Number of points. Start frequency 1, stop frequency 1 megahertz. Okay, let's set this up here. And let's run. What did I, oh yeah, AC1. So I need to right click on my source, set this equal to 1, say OK. Now click run. OK. Now we can come over here and change the scale to logarithmic. And we should see this type of curve right here. This is the gain, and this dashed line is the phase. So we see that we have a gain of less than 12 dB. For let's get rid of this pane, delete this pane. There we go. say starting around 1, 2, 3, 4, 3 and 400 hertz. Between 3 and 400 hertz, we have our gain, and it's pretty flat until you get up to about 80, 90, 100 kilohertz. It starts to drop. So our simulation was at 100 kilohertz. So if we backed it off a little bit, said 50 kilohertz, we would have more gain. So that was like 2.5, somewhere in there. So we could do better if we just changed that frequency right there to a lower number. We would have seen a higher gain. Let's see. And then the shape of this right here is, I was playing around earlier, edit simulation command. If I take off these points here, that becomes less accurate. So anyways, you can play around with it yourself, but I wanted to show those two, transient response and AC, what was it again? AC sweep? AC analysis. Thanks. Hope you enjoy the video.